This is mathheals.com, where you can find more links to math YouTube videos and computer science. Let's take a look at absolute value equations and inequalities. Now our absolute value equations says if you have the absolute value of something is equal to something else, then you drop the absolute value, set it equal to positive the other side, and you drop the absolute value and set it equal to negative the other side. Now it really is as vague as what I just said. Absolute value of something is equal to something else. There's a couple of oddball cases, but you can have anything in here, just as long as you get the absolute value of something is equal to the other side. Now the absolute value has to be by itself. Can't have any numbers in front of it, can't have any numbers after it. So you have to get it by itself. Let's look at our first problem. We've got the absolute value of x minus 7 is equal to 4. Now the absolute value is by itself on the left side. So what's inside is our p and the other side is our q. So our formula says we're going to have p is equal to q and p is equal to negative q. Everywhere there's a p, I'll plug in x minus 7. Everywhere there's a q, I'll plug in 4. So I got x minus 7 is equal to positive 4, and x minus 7 is equal to negative 4. Usually people don't write the formula down. When you got the absolute value equal to something, you drop the absolute value, set it equal to positive the other side, and you drop the absolute value and set it equal to negative the other side. Now we solve each one of these separately. So on this one, I'm going to take the negative 7 and move it to the right side. So we got x is equal to 4 plus 7, or 11. On this one, I'll take the negative 7 and move it to the right side. And you get negative 4 plus 7. Well, negative 4 plus 7 is 3. So those would be my two answers. Let's take a look at another example. We got the absolute value of 5x plus 2 minus 6 equals negative 2. Now to use this formula, the absolute value has to be by itself. Well, we got a minus 6 here. I'm going to take that and move it to the right side. So we get the absolute value of 5y plus 2 is equal to negative 2 plus 6. Negative 2 plus 6 gives us 4. Now sometimes people don't get the absolute value by itself and they just dive right into the formula, and sometimes they get the right answer. So they get thinking I'm full of it, that you don't need to get the absolute value by itself. Sometimes you will get the right answer, but not all the times. So the safe bet is to get the absolute value by itself first. Then our formula says we drop the absolute value, set it equal to positive the other side, and we drop the absolute value and set it equal to negative the other side. So we got 5y plus 2 equals 4, and 5y plus 2 equals negative 4. Now we want to solve for y. So here I'll take 2 over. And we get 5y is equal to 4 minus 2. 4 minus 2 is 2. And then divide both sides by 5. And these 5's cancel. And we got y is equal to 2/5. Now on our other one, we'll take the 2 over to the right side. And we get 5y is equal to negative 4 minus 2. Combine together numbers, negative 4 and negative 2 is negative 6. And then divide both sides by 5 to get the y by itself. Those 5's cancel. And we get y is equal to negative 6/5. And those would be our answers. Let's look at another one. Got the absolute value of 3x minus 1 over 4 is equal to 5. Okay, well, the absolute value is by itself, so we can go ahead and apply our formula. Formula says you drop the absolute value, set it equal to positive the other side, and you drop your absolute value, and you set it equal to negative the other side. So we set it equal to positive 5, we set it equal to negative 5. Now I'm going to solve each one of these separately. Now these are just linear equations. First step, get rid of parentheses, don't have any. Second step, get rid of fractions. Multiply everything by the LCM of all your denominators. Only have one denominator, so that is our LCM. So multiply both sides by 4. And do that, those 4's going to cancel. And we got 3x minus 1 equals 4 times 5 gives us 20. Third step, get everything with an x on one side, numbers on the other side. So I'll take that negative 1, move it to the right side. And it becomes a positive 1. Combine together numbers at any step. 20 plus 1 is 21. And the last step is divide both sides by the number in front of your x. So divide both sides by 3. And we get x is equal to 7. Well, we'll solve this other one the same way. Get rid of parentheses, don't have any, get rid of fractions. Multiply everything by the LCM of all your denominators. So multiply both sides by 4. Those 4's cancel. And we got 3x minus 1 equals 4 times negative 5 is negative 20. Get everything with an x on one side, numbers on the other side. So I take the negative 1 over. And we get negative 20 plus 1. Combine together numbers at any step. Negative 20 plus 1 is negative 19. Then divide both sides by the number in front of your x, which is 3. Those 3 is going to cancel. And we got x is equal to negative 19 thirds. And that's our answer. Now this next one's kind of an oddball case. Let's see, we got the absolute value of 7x minus 1 is equal to the absolute value of 3x plus 3. What we're going to do is we'll drop the absolute value from one side. That's a little trick to this one. So if you got the absolute value on both sides, just drop it from one of the sides. And then you apply your formula just like normal. Now we got the absolute value of something is equal to the other side. So we'll drop our absolute value, set it equal to positive the other side, and we'll drop our absolute value, and we'll set it equal to negative the other side. Well, let's solve this one on the left first. There's no parentheses, there's no fractions. Get everything with an x on one side, numbers on the other. So I'll take 3x over, and I'll take negative 1 over. So we're getting everything with the x on the left side, and we're getting all the numbers on the right side. Combine together like terms, 7x minus 3x is 4x. Combine together numbers, 3 plus 1 is 4. Divide both sides by number in front of your x, so divide both sides by 4. And we get x equals 1. Now remember, if you have a negative in front of your parentheses, it's going to flip the sign of everything inside. So this negative here is going to flip the sign of everything inside the parentheses. So we end up with 7x minus 1 is equal to negative 3x minus 3. Well, now I get everything with an x on one side, numbers on the other side. Take negative 3x to the left side, becomes a positive 3x. Take the negative 1 to the right side, becomes a positive 1. Combine together like terms, 7x plus 3x is 10x. Combine together numbers, negative 3 plus 1 is negative 2. And last step, divide both sides by the number in front of your x, which is 10. So divide both sides by 10. These 10s cancel. And negative 2/10 reduces to negative 1/5. And those are our answers. Let me Now this next one is another oddball case. Let me start a new page here. Okay, number 5. We work the problem down. We get the absolute value of 5x plus 1 is equal to negative 2. Okay, we got the absolute value by itself, and we got it equal to a negative number. Well, remember what the only purpose of absolute value is. It makes whatever's inside positive, or it can be 0. So when we're asking when is an absolute value equal to a negative number, well, it's never equal to a negative number. So this is a no solution. So again, if you get the absolute value by itself equal to a negative number, it's a no solution. And here we got another absolute value equation. We have it equal to a negative number, so it looks like another no solution. But the absolute value isn't by itself. So to get it by itself, we're going to have to divide both sides by negative 4. And do that, those negative 4's cancel, and we've got the absolute value of x plus 3 is equal to negative 16 divided by negative 4 is a positive 4. So once we get the absolute value by itself, we see it's no longer equal to a negative number. And now we can apply our formula, our rule. Drop the absolute value, set it equal to positive the other side, drop the absolute value, and set it equal to negative the other side. Here I'm going to take 3 over. I'll take 3 over here also. So we got x is equal to 4 minus 3, or x is equal to 1. And here we got negative 4 minus 3, which is negative 7. And those are our answers. This is another oddball case here. Work the problem down. Absolute values by itself. And you got to set it equal to 0. Well, this is the oddball case where you got an absolute value equal to 0. Well, think what our formula says. Drop the absolute value, set it equal to positive the other side. Drop the absolute value, set it equal to negative the other side. But positive 0, negative 0 is just 0. So this problem just becomes x plus 7 is equal to 0. Or x is equal to negative 7. And that's our answer. Now the next thing in this section is absolute value inequalities. And we have two cases. One of them where we have the absolute value of something is less than something else. If you got it in this form, then you can rewrite it in this manner. And we've got our second case where we have the absolute value of something is greater than something else. Then if you got in that form, you can rewrite as p is less than negative q, or p is greater than q. Now what that or means, it doesn't mean you can pick one or the other. It has to be all of this when you're working those problems. A lot of people, I think, will just pick maybe one side of it and not even worry about the rest because they think the or means I can pick either one. That's not what it means. Let's take a look at one of these problems. These problems aren't too bad, but there's like tons of oddball cases. Okay, so we have the absolute value of 9x plus 2 is less than or equal to 10. Well, the absolute value is by itself on the left side. That has to be that way for these formulas. Now, it's not a less than, it's a less than or equal to, but it doesn't matter. These are interchangeable. Less than and less than or equal to, you use the same formula. So what's inside the absolute values are p, and the other side is our q. And our formula says negative q is less than or equal to p is less than or equal to positive q. So wherever we have a p, we'll plug in 9x plus 2. Wherever we have a q, we'll plug in 10. So I got negative 10 is less than or equal to 9x plus 2 is less than or equal to positive 10. Now, if you remember these from before when we solved compound inequalities, if you got three sides, your goal was to get the x by itself in the middle. So our first step was to get rid of parentheses, don't have any. Second step is to get rid of fractions, don't have any. Third step is to get everything with an x in the middle, numbers on the other two sides. So I'll take 2 over there and take 2 over there. So we get negative 10 minus 2 is less than or equal to 9x, is less than or equal to 10 minus 2. Remember, when you take anything across your inequality, the sign changes. Well, negative 10, negative 2 is negative 12. Combine together numbers at anywhere in math. And 10 minus 2 is 8. Well, our last step is to divide all three sides by the number in front of our x, which is 9. So we'll divide the negative 12 by 9, the 9 by 9, and the 8 by 9. Now these 9's cancel. 12 and 9 are both divisible by 3. Negative 12 divided by 3 is negative 4, and 9 divided by 3 is 3. And doesn't say how to write the answer, so we're probably good there. They might put it in interval notation though. So less than or equal to means bracket. So I got bracket on the negative 4/3. Less than or equal to here means bracket. So we got a bracket on the 8/9. And those are answers. Okay, number 9. We've got 4 absolute value of x minus 7 minus 3 is less than 9. Now we can't use these formulas unless the absolute value is by itself on the left side. So let's first take this negative 3 and move it over. And when we take it over there, it becomes a positive 3. And 9 plus 3 is 12. Then we want to divide both sides by 4 to get the absolute value by itself. And we'll have the absolute value of x minus 7 is less than 3. Well, now it's in our form. Fits our form case 1. Absolute value is less than something. So we can plug it in. This is our P and this is our Q. Our formula says negative Q is less than P is less than positive Q. So everywhere we have a P, we'll plug in x minus 7. Everywhere we have a Q, we'll plug in 3. So I got negative 3 is less than x minus 7 is less than a positive 3. Try and get x by itself in the middle, so I take negative 7 over the other two sides. And we get negative 3 plus 7. And we get 3 plus 7. Well, that gives us 4. And then this gives us 10. And this would be interval notation. Less thans mean parentheses. Let's take a look at this one. Get the absolute value of x plus 7 is greater than or equal to 3. Okay, the absolute value is by itself on the left side, and this time it matches case 2 because it's a greater than. Specifically, it's a greater than or equal to, but remember these are interchangeable. So this is the formula we're going to use. What's inside your absolute value is your P, the other side is your Q. So I'm going to have P is less than or equal to negative Q, or P is greater than or equal to positive Q. Now everywhere there's a P, we'll plug in x plus 7, and everywhere there's a Q, we'll plug in 3. So we got x plus 7 is less than or equal to negative 3, or x plus 7 is greater than or equal to a positive 3. Now we're going to solve for x. So I'll take this 7 and move it over. Same here. So we got x is less than or equal to negative 3 minus 7, or x is less than or equal to negative 10. On this one, take 7 over, we get 3 minus 7. So we get x is greater than or equal to negative 4. And there's an or between them. that's our answer. Let me start a new page. And we've got the absolute value of negative 4x plus 3 minus 10 is greater than or equal to 0. Okay, I have to have the absolute value by itself. So I'm going to take the negative 10 and move it to the right side. So we get the absolute value of negative 4x plus 3 is greater than or equal to positive 10. Now this is case 2, the greater than. So what's inside the absolute values are p, and this is q. Our formula says p is less than or equal to negative q, or p is greater than or equal to positive q. So wherever there's a p, I'll plug in negative 4x plus 3, and wherever there's a q, I'll plug in 10. So I got negative 4x plus 3 is less than or equal to negative 10, or negative 4x plus 3 is greater than or equal to positive 10. I want to solve for x, so here I'll take 3 over. And we got negative 4x is less than or equal to negative 10 minus 3. Negative 10, negative 3 is negative 13. Want to get x by itself, so we now have to divide both sides by negative 4. And remember, if you divide both sides by a negative number, you have to flip your inequality. So this becomes a greater than or equal to. So we get x is greater than or equal to 13/4. And we'll do the same thing on this one. Take the 3 to the right side, becomes a negative 3. So we got 10 minus 3. 10 minus 3 is 7. And then divide both sides by negative 4. And again, when we divide both sides by a negative number, we flip our inequality. So this becomes a less than or equal to. So we got x is less than or equal to negative 7/4, with an or between them. And that's our answer. Well, now we start talking about our oddball cases. Okay, so we got these may not include every oddball case, but these are kind of the big ones you run across. Okay, we worked the problem down. Got the absolute value by itself. We've got it less than a negative number. Now think what an absolute value does. It makes whatever's inside it positive or can be 0. So when we're asking, when is an absolute value less than a negative number? It's never less than a negative number. So this is a no solution. Okay. Now here we got another absolute value less than a negative number, so it looks like another no solution. But remember, the absolute value has to be by itself. So let's go ahead and divide both sides by negative 3. Now remember, when you divide both sides by negative 3, it flips your inequality, so this becomes a greater than. So those cancel. And negative 9 divided by negative 3 is a positive 3. Well, now that we can actually work this problem, it went from what looked like a no solution to a problem we can work. And notice it started out as a less than, which was case 1, and it switched to a greater than, which is case 2. Now this is P, and this is Q. For the greater than, our formula says P is less than negative Q, or P is greater than Q. You have to plug in all of this. P we said was x plus 5, so we got x plus 5 is less than negative 3, or x plus 5 is greater than a positive 3. And then I'll take the 5 over. We get negative 3 minus 5, or x is less than negative 8. Here, take the 5 over, becomes a negative 5, and 3 minus 5 is negative 2. So we get x is less than negative 8, or x is greater than negative 2. And that's our answer. Lots of oddball cases. Let's take a look at this one. Okay, we got absolute value of x plus 5 is less than or equal to 0. Well, think what we said earlier. We said absolute value cannot be equal to a negative number. So when we're asking when is it less than or equal to 0, it can't be less than 0. Less than 0 is negative. But it can be equal to 0. So this problem actually becomes x plus 5 is equal to 0. And then you solve for x, so take the 5 over, and we get x is equal to negative 5. Now here we got the absolute value of x plus 5 is greater than negative 2. So we're asking when is an absolute value greater than a negative number? Well, absolute value makes whatever's inside positive or 0. Whether it's positive or 0, both those are greater than negative 2. So this is negative infinity to positive infinity. It doesn't matter what you plug in there, it'll be greater than negative 2. Like if I put 7 in here, 7 plus 5 is 12. Absolute value of 12 is 12. That's greater than negative 2. If I put negative 20 in here, negative 20 plus 5 is negative 15. Absolute value of negative 15 is 15, which is greater than negative 2. So it's always greater than negative 2. This, whenever you get the absolute value by itself greater than negative number, then it's always a negative infinity, positive infinity. Now I'm not going to actually solve this one. I just want to do the setup on it. This is not so much an oddball case, and I don't think you necessarily see these a whole lot in intermediate algebra, but our current college algebra book has a lot of these. This is in the wrong form. Those two cases we had the absolute value on the left side. So we're going to flip these around, put the absolute value here and put the 3 here. Now you can flip them around, but you can't lose your inequality relationship. See how the small end here opens up toward the 3? When you flip it around, the small end has to open up toward the 3. And now this is case 2, so we can continue down and work that problem. Okay. Working some problems down, you come up with x is greater than 2 or x is greater than 5. You worked all your steps correctly, you look in the back of the book, and they appear to have forgot part of the answer. Let's graph this and just see. Here's 2, and here's 5. X is greater than 2. Well, that'd be shaded this way. X is greater than 5. That would be shaded this way. Now remember, the or is where anything is shaded. Oh, wait a minute. Yeah, anything is shaded. Well, the 2 includes the 5, doesn't it? So in the back of the book, all they'll have for their answer is x is greater than 2. So again, sometimes you're working a problem down, you did it perfectly, and you're just like, what? Why'd they drop half the answer? If you look at the graph, it'll be obvious. Okay. Let's look at number 18. Work a problem down. We get x is greater than 2, or x is less than 6. Here's 2, and here's 6. X is greater than 2. That would look like this right here. X is less than 6. Would look like this right here. Now the or, remember, is where anything is shaded. Well, it's shaded everywhere. So the answer here would be negative infinity to positive infinity. Again, this is another one. You get your answer and you feel good about it. Look in the back of the book and it's something entirely different. But if you look at the graph, it'll probably make sense. Okay. Work a problem down. We get this right here. Well, this is in the wrong form. Remember when we had the three-sided compound inequalities, we want a smaller number on the left side and a larger number on the right side, and then x in the middle. So we're going to flip everything around. Now this small end of the inequality opens up toward 2, so small n has to open up toward 2. Large end opens up toward the 4, so the large end of the inequality has to open up toward the 4. And now it's in perfect form. Smaller numbers here, larger numbers here, and these are either less thans or less than or equal to's. That's not really an oddball case. It's just something you have to do an extra step on. Okay, work the problem down, and we got 3 is greater than x is greater than 5. Well, there's a problem here. Smaller numbers here or larger numbers here, that's good. But these symbols here have to be either lessons or less than or equal to's. So that doesn't fit. Well, I could flip them around like this. Put the 5 over here, 3 over here, and that way, see how the small end here opens up toward the 5, small end opens up toward the 5, large end in inequality opens up toward the 3, large end opens up toward the 3. Now my symbols are good, but now the numbers are wrong. Larger numbers over here, smaller numbers over here. There's no way I can write it in a proper form. If you can't write a 3-sided inequality in proper form, then that means it's a no solution. And I think that's the end of that section. So go ahead and save that.